Hello everyone, welcome to the course of data structures. Today we're going to start our first lecture of data structures, and we're going to speak about arrays. We have used them in many situations, but today we're going to cover more interesting properties of arrays in terms of data structures. Later we're going to cover other data structures like linked lists or trees, and we're going to see the differences between them. For now we're going to consider arrays. So to just let you know the difference between arrays and just normal variables, when you declare a variable just like this, int x, you're basically reserving a piece of memory with the size 4 bytes. Like if you work with Java, the size of x is going to be 4 bytes. So these are 4 bytes, which is 32 bits, right? So this is basically what you do. You reserve, having this command or this statement is just reserving or commanding the program to reserve in memory 4 bytes for this variable. Then we can use it by having some values inside, right? Now, if you do the same with arrays, we are actually reserving not only 8 bytes, but we reserve 8 bytes if we work with ints. If we work with integers, 8 bytes times the size of the array. So that's 8 bytes here and here and here, so that's 3, okay? And we should know that having this statement is again similar to this one. We're just reserving some memory for the variable x, okay, which is now an array. And arrays are contiguous data structure. That means that this piece of memory, okay, used to store the first element is just contiguous to this one and to this one. So all of the three are just direct neighbors of each other. And also that means that if we know the address of the first element, okay, so the first element is 8 bytes, these 8 bytes, comes next to it the next element, this one and this one. So by knowing the first element, we can access the second and third. And if you have an array that has 100 elements, so again, if you know the first element is address, you can access the second and third just by incrementing the address, right? So that means that basically, if we know the address of the first element, it's very easy to access any element in the array. Why is that? Because this kind of data structure is contiguous. That's why accessing an element in an array based on the index or the address is going to be big O of 1. Big O of 1 means constant time, right? This is a theoretical introduction about array, and now let's move to the practice with NetBeans. Okay, so here's NetBeans. I'm going to create a new project. Okay, so this project is going to be Java application, and I'm going to save it in data structures, and I'm going to call this array. Okay, so the application is called array, and it's going to have a package array, and I'm going to call the main class as a class that has the main method. I'm going to call it driver or manager or whatever you want. I'm going to just call it driver. Okay, so in here we're going to write our demonstration code. But first, I'm going to create a class array. So I'm going to call this array, finish. So basically, in this class, we're going to use arrays, and not in the same way that we use array, but we're going to do manipulation of this array. So we can insert data into arrays or delete data from the arrays, and we're going to see the time complexity of these operations. So first of all, let's create the fields. So for an array, it must have size, so int size, right, or length, and also it's going to have a data. Okay, so the data for now I'm going to consider it as int, but then we're going to make it generic later. So int data, and this is the array basically. So that's a vector for an array. So data like that, right? Now we can have the constructor and the getter and setter for these fields. So insert code. Constructor, we don't want the size, we want the data. Okay, so generate. Okay, we have this, and then once we have the data, okay, we can update the size. So this dot size is going to equal to the size of the data. So data dot length, right? Now after that, what I want to do is to have accessors to the size, or getters and setters for the size and data. So I'm going to insert code here again. Getter and setter, but this is going to be for the data, okay, not the size. Okay, I don't want to set the size. Okay, so just the data, right? And I'm going to encapsulate this. Okay, for the size, I want to get the size. Okay, so insert code again, and this is getter, and for the size only, encapsulate that. Okay, so now we have basic methods. Okay, now we can actually make a test on that. So we can create an array. We can say int my array, or int data. I'm going to call it data is new int of, let's say, 10, right? And then we're going to create an array class, right? And I'm going to call it my array for now. And this is new array of data that takes data, right? So now we have a class that holds the array data. Okay. The only difference now between this class, this is a user-defined class array. The only difference is that here in this class we can have some operations for inserting new data or deleting some data. We cannot do this with the array, the standard array that comes with Java. Okay, right? One reason for that is that, again, that the data is reserved with this statement, right? The memory is reserved with this statement in a specific address with a specific size, so you cannot manipulate this, you cannot edit it, basically. But we're going to see how to do that, inside the class. Now, to check that we did the right thing, just try to print the size. Okay, print system my array dot size. Oh, that's get size, right? Let's run this and see. So yes, the size is 10. That makes sense. Now we have the declaration only of the data, but we don't set the data. We can actually say data of 0 is 0, and so on. Or we can have a for loop to do that, and then we can also access this. Okay, but for now we can do some modifications. So for this, instead of just having it accepting integers like this, we're going to make it accept any data type. So how to do that? We can use generic data. So we're going to add e here, and then for the data, the type is going to be e. Okay. So we need to change this each int here into e. So e here. So e here, and then what else? Here e. Or T or G, whatever. Okay, I'm going to just call it E. That's it. Okay, now let's try this with different arrays. So we can just say int, not int now. We could use int, but you can use double. An array like that. Okay, data is new double of 10 that has a size 10. Right? And then we can say array, and then it takes double here, okay, the generic term, and my array is new double, sorry, new array of double that takes data. Right? And we can just remove that. Okay. Now we can say print systems.out print len, and then here my array dot get size, and let's see. So again, it's 10. So we just wrote the very basic functions. We need to add more functions. Now let's add some more methods to this class here. So one of the interesting method is the toString. So toString could be used to print the data, for example, here. The thing is, toString can come. The thing is that toString is actually one of the functions by default of the array class. Why is that? Because array class or any class in Java is inherited from the object class, and the object class has a toString function. So by default we have a toString to any class. Okay, but so by default we have a toString function for any class. However, the way it works might be different. So let's try how it works here. So we can call myArray.toString. Actually, we don't have to say the toString. We can just use it when we inside the println, because println is basically taking a string, can take a string. So when you pass it an object, it tries to convert it to a string using the toString method. So we can just remove that. So the toString method is going to be called automatically. Now we can see here, this is the output of the toString method, but it's not very meaningful, or this is not what we want. What we want is the data. Okay, what we have as data here. So we need to change the toString method or to override it, basically. So let's get to the array class again and override the toString. We can just right click here and insert code and then toString. Okay, so we can modify this. So string is going to be like this, string result going to be like that, and we can just add this at the end, right? So we can say for end I equals to 0, I less than this dot size I plus plus. Do what? Results is results plus data at I. Okay, and at the end, results is results plus this. Right, and then what we need to have to return result. Okay, that's it. So let's try and see how it works. Oh, we have null, 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 null. Why null? Because we haven't initialized the data. So we can use for loop like this, and I equals to 0 and I less than 10, because 10 is the size of the data, and I plus plus. Do what? We can just say data at I equals to some double. So we can just cast I, or I times I, like that. So we do casting of this expression to double, and since this is a double class, it could be converted. We can have a conversion from the primitive data type double to the double class. So that's accepted, right? So now the data that we have here, the data array contains 0, 1, 4, 9, etc., until I believe 81, right? So let's see if this is printed here. Actually, it's better to have some space here. So results plus space or tab, whatever. Okay. So let's try save and run. So you can see here 0, 1, 4, 9, 16 up to 81. So this is actually what we want. We can remove the word array from here. We can just write data instead. So okay. So this is a print. The toString method. We can use it this way, or we can have a print method. Okay, so print method or toString, doesn't matter. Okay, so actually we can have a print method also with that. So we can say public void print, and it's going to call the toString. Okay, so it's going to just say system dot out dot print or this, or print all that. Print this, and this actually is going to be converted to string using the toString. Okay, so we can instead do this here. So we can say print my array dot print. That's it. Let's see. You can see it's the same result. Okay, so now we did the basic functions to show the data. Okay, now we wanna do some manipulation of the functions. Okay, or some access of the function, access to some elements, and then some manipulation. So we can have, for example, an access function to any element. So we could say element at, get element at. Okay, so we can have public. Okay, and then e. Why is that? Because the element we're getting is of this type. Get element at any index. So end index. Right, and this is a very simple function. Basically, it's going to return data at index. Okay. Okay, so this is a very basic one, and the time complexity of this is big O of 1. Okay, because it just accesses any element by index, and that's easy once we have the address of the first element. Okay, that's easy for the computer. Now, let's get to the difficult parts. If we want to insert elements, so public void insert or delete. Okay, so let's say insert some data in at an index. Okay, so how to do that? So the data is E of type E. So let's say E element, right? So this is the element we need to insert at an index, right? This is what we want to do. This is a difficult function and it takes some time. The complexity, some complexity of this is actually big O of n, right? Why is that? Because we cannot insert directly to a function. We cannot insert directly to an array because we cannot change the array. So the data array here, we can change the data inside, but we cannot change the size. Okay. So once you reserve it, you cannot change it. And how you reserve it? Reserve it using this statement. Okay. So what to do next? We create a new array. The new array is going to be of type object, like that, because we can't create an object of a generic type. So we create an array of objects, right? And I'm going to call it new data, okay, or modified data, whatever. And then this is going to be new object, right? Of what is the size? The size we're going to add here only one element. So the size is going to be the size of this array, the size of the data, the previous data, which is the size of this class. Okay, so this is going to be the size, right? And then plus one because we're adding another element. Okay, so we're reserving now a different size, okay, of memory, okay, for this array. So this is going to be this dot size plus 1. Now we have the array. We want to move the data up to this index, right? So sorry, up to this index, right? So if our data is 0, 1, 2, 3, 4, 5 up to 10, and we want to insert at index 3, that means we're going to have data up to index 2 from the old vector, and then, or the old array, and then this data, and then starting from 3 again from the old array, we start add to the new array. So let's do that. So we're going to say for int I equals 0, I less than, now less than what? Less than this one, sorry, this one, index. Okay, less than index. Do what? And I plus plus, do what? New data of I is old data of I. That's fair, that's okay. Now, what we need to do next, we're going to say new data at index, this index here, equals to element, right? And then we're going to have another for loop to set the data from I is index plus 1 and I is less than the new size. This is a new size, okay? This is the size plus 1, okay? Actually, we can update the size here. We can say this dot size is this dot size plus 1, right? Or this is size plus plus, or size plus plus, right? And then we can have here size. This is a new size because we added already one. Okay, and then in here, this is going to be size. I plus plus to what? The new data add the I is going to be I minus 1. Okay, why is that? Because we our data we didn't include the index, right? In our data we didn't include the index. So let's have this example. So if the data is again 0, 1, 2, 3, 4, 5, and we want to insert at 3. Okay, so that's index 3 because 0, 1, 2, 3. Okay, if we want to add here, so we need to copy this first. Okay, using this for loop. So I starts from 0 to 2 because the index is 3. So we're going less than 3. Okay, makes sense? Now after that, we want the new data to have the element from outside. Let's say 5. Okay, so this is added again. So we have the new. So we have the new data is going to be 0, 1, 2, and then here we're going to have new elements. So I'm going to say, let's say 5. Okay, so that's new coming from this method, and then left to us 3, 4, 5. Okay, so 3, 4, 5 are what? So the index we want to add is 3. We added already 5 here at 3, and then next the new data starts at 4, 5, 6. Okay, so that's 4, 5, 6 is going to be at starting from index plus 1, because index is 3, we added 3 already. Now to continue, we have here index plus 1, which is 4, 5, 6, right? So we want to add here 3, 4, 5, this here, added here. Okay, where they are added, starting from index plus 1. So here, index plus 1. However, to access this old data, this set of old data, we're having the first element is actually at index, right? Not index at 1, not index plus 1. That's why we move back by 1. Okay, so finally we wanna set this data to new data. Okay. Now there is data incompatible types because new data is of type object, and data is of type array of generic array. So we want to do casting like this, okay, to the array. So the array of objects is casted to be generic object. Why didn't we just use generic arrays here creation? So this is not allowed in Java. Like you cannot create generic arrays. Okay, so it seems for me that this is a good method to insert data. So let's just run and see. Okay, so let's get to the driver. We have already the data here. Okay, and we use the print method. Okay, now my array, we want to insert some items. So we have here, how many items we have? 10 elements, right? My array dot insert what? Insert some data, let's say 55. Okay, where? At index 3. Okay, so the data we should be like this: 0, and then 0.0, okay, and then 1.0. Index 2 is going to be 4.0, and then 55.0. Right, this is what we insert. We insert at index 3, so 0, 1, 2, 3, and then after that we should have 9 again, 9, 16, etc. So 9, 16, so on. So let's see if we print my array after that, what happens? Dot print. Okay, let's try and see. Yes. Okay, 0, 1, 4, 9, 16, 25, 36, etc. And then we have 0, 1, 4, 55, as you can see. Okay, so inserting here means that we need to create a new array and make copies. Okay, so we copy all the elements, right? Even though you want to insert only one element, you have to copy all the data. That means you have to work on n elements. What are the elements? Or what is n? N is the size. Okay, so if you have n elements, you have to work n times. So you have to have your for loop working n times. That's why insertion to an array is big O of n, and you have to do some manipulation. You have to copy the data. You cannot insert to a standard array. Okay.